So, good evening. So, we will proceed quiz number 3 in combustion engineering. Topic, dual combustion engine. So, this is Jerome Barcelina discuss. We'll discuss the problem number 1. So, we already drawn the PV diagram and the test diagrams, and we already put the all given. So, as we know, all the graph of the dual combustion is like this. In this area, uh, constant volume heat addition. In this area, constant pressure heat addition. And then in this area, constant volume heat rejection. So, we will proceed with the problem. So, we will read the problem number 2. Number 2, state 1 for dual combustion engine is pressure 1 is equal to 1 atm. Temperature is equal to 60.3 Celsius. Compression ratio is 18. At the end of the constant volume combustion process, pressure is 7,695 kPa. Cut-off ratio is 1.5 based on 1 kilogram per cycle of hot air with K 1.31. Determine the percentage clearance PV anti in each corner of the cycle. See the work net, the efficiency, and the mean effective pressure. So, we will look for A. So, A for the percentage clearance. So, we all know that compression ratio is equal to 1 plus C over C. So, substituting the given, 18 is equal to 1 plus C over C. So, solving this equation, 18 1 plus C over C is equal to 0.05 0.0588. So, times 100% is equal to 5.88%. So, we already know the percentage clearance. So, letter B, we will determine the PV, the pressure, temperature, and volume in each corner. So, we mass is equal to 1 kilogram. So, now we will look for the volume 1 because we don't have the volume 1. So, by using the universal gas equation, ideal gas equation, PV MRT. So, V1 is equal to MRT over P. So, substituting the given 1 kilogram times R of air is 2.87 kilojoule per kilogram Kelvin times the temperature, which is 333.3 Kelvin, over the pressure 1. So, we have a pressure 1 of 1 atm. We all know that 1 atm is equal to 101.325 kPa. 101.325 kilonewton per meter squared. So, kilojoule is equal to kilonewton kilonewton meter. So, now we will cancel all the the unit kilogram, kilonewton, Kelvin. So the left unit is cubic meter. So solving for this equation, we will have 0.944 cubic meter. So we have the volume 1. So all PVT in state 1 is completed. So we will proceed to point 2. So first we will look for the volume 2. So as we know, compression ratio is equal to B1 over B2. So it's equal to 18 times 0. What is the volume? 9.944. 9.944 divided by 18. So 0.944 divided by 18. So we will have a volume 2 of 0.0524 cubic meter. So we have the volume 2. So next, we will look for the temperature 2. Temperature 2 by the relationship of this equation of the study at the thermo. Temperature 2 is equal to the compression ratio raised to K minus 1. So T1 is equal to 333.3 Kelvin times 18 raised to 1.31 minus 1. So solving this, we will have an answer of 816.53 degree Kelvin. So now we will proceed to the pressure 3. Pressure 3 over pressure 1 over the compression ratio RK over K, and that 101.325 times 18 raised to 1.31. So solving this, we will have a pressure 2 of 4,468.11 kilopascal. So we already completed at point 2. So we will proceed to the point 3. At point 3. So here we go at point 3. So pressure 3 is given. It is stated in the problem. that there after the compression. So pressure 3 is 7,695 kPa. So next we will look for the temperature 3 by the relationship studied in thermo. Temperature 3 over temperature 2 is equal to P3 over P2. So substituting T2 816.53 times pressure 3, which is 7,695 over pressure 2, 4,468.11. So solving this equation, we will have a temperature 3 of 1,406.23 degree Kelvin. So we will proceed to volume 3. So volume 3, as we look in the graph, volume 2 is equal to volume 3. So we have already the volume 3 which is equivalent also to the volume 2, equal to 0.0524 cubic meter. So we completed the temperature volume at state 3. So we proceed to at state 4. So state 4 volume 4 is equal to the cut-off ratio, which is 1.5 times the volume 3. Volume 3 is equal to 0.024 cubic meter. So solving this, ay ang hirap. 1.5 times 0.0524. Minupindot. Wait. 1.5 times 0.0524. So, here it is. We will have volume 4 is equal to 0.0786 cubic meter. So, we will proceed to the temperature 4. So difficult. Temperature by the relationship again, T4 over T3 equals to V4 volume 4 over volume 3. So transposing volume 3 ay temperature 3 is 1406.23 times volume 4, which is 0.0786 over volume 3, 0.0524. So solving this, 1406.23 times 0.0784 86 over 0.0524. So we will have an answer of 2109.345 degree Kelvin. So so we lack the p pressure pour. So pressure pour. So we will look for the graph. So as we can see, pressure 3 is equal to pressure 4. So pressure 4 is equal to pressure 3, which is 7,695 kilopascal. So we completed the volume, temperature, and pressure in state 4. So we proceed to state 5. State 5, at state 5. So by the relationship again, temperature 5 is divided by temperature 4 times the volume 4 over volume 5 raised to k minus 1. So substituting volume temperature 4, which is 2109.345 times B4 which is 0.0786 over B5. So B5, as we can see in this diagram, B1 is equal to B5. So B1 0.944 raised to 1.31 minus 1. So let's have calculator. 2109.345 times 0.0786 times 0.944 raised to 1.31 minus 1. Ayan, we have mistype. So here 976.084 Kelvin. So B1 is equal to B5. B1 B5 0.944 cubic meter. So we lack of pressure 5. Pressure 5 by relationship again, pressure 5 over pressure 1 is equal to temperature 5 over temperature 1. So transposing the equation and substituting, P1 is equal to 101.325 kilopascal. T5 is 976.084 over temperature 1, which is 333.3 Kelvin. So cancel that. So using again the calculator, 101.325 times 976.084 976.0333.3. So yun, the calculator 296.735 kilopascal. So uh, we already computed all the pressure, volume, and temperature in each point. So next we will solve for the for the efficiency, work, and the mean effective pressure. So we will change, since it is already full. So here, so we will look for the work, the efficiency, and the mean effective pressure. So work is equal to heat added at the constant volume plus heat added at the constant pressure minus the heat rejected at the constant volume heat rejection. So in this, Q added is equal to M CP or CB times T3 minus T2 based on the graph that we have discussed later, times mass CP times T4 minus T3. So that, but since it is hot air, we will look for the CV and the CP. So CV is equal to R, which is the universal gas constant, over K minus 1. So 5.287 kilojoule per kilogram Kelvin over 1.31 minus 1. So we will have an answer of 0.9258 kilojoule per kilogram Kelvin. So in CB equal to KR K minus 1. So in this, we will 2.87 times 1.31 over 1.31 minus 1. So we will have an answer of 1.2128 kilojoule per kilogram Kelvin. So if we proceed to the in this, so we already the mass is 1 kilogram, so we don't need to write in this. So CB 0.9258, temperature 3, we will need this. Kabaliktad. So temperature 3 is 1406.23 minus T2. Wait, we will fix this. So, we will continue. Temperature 3. Isa temperature 3. Yun. Temperature 3 minus temperature 2. 816 816.53 plus MCB. CP is equal to 1.2128 times temperature 4. Temperature 4, which is 2109.3345. 345 minus T3 06.23. So solving this using the calculator, 0.9258 times 1406.23 minus 816.53 plus 1.2128 times the temperature to 1.21 temperature for 2109.345 minus 1406.23. So we will have an answer of one will the marker will hindi na nagsusulat 1398.68 kilojoule. So we already have the Q added. So now we will work on the Q rejected or the heat rejected in the volume, constant volume. So mass times constant volume, CB minus times 2 temperature 5 minus temperature 1. So CB 0.9258 times temperature 5 temperature 5 976.084 minus that temperature 1 333.3. So using again the calculator, 0.9258 times 976.084 minus 333.3. So we will have, wait, may some calculator error. Where is the temperature? So yan, we will have an answer of negative 595.09. So as we go back to the equation, total work total work is equal to work added in constant volume and constant pressure minus the heat rejected. So 1,398.68 minus 595.09. So using again the calculator, kawit na ako. 1,398.68 minus 595.09. So there, we will have a total work of 803.59. 803.59. So that is kilojoule. So next will the efficiency. We all know that efficiency is equal to total work over heat added. Total work is 803.59 over the Q added 1,398.68 kilojoule. So using again the calculator, 803.59 over divided by 1,398.68. So we'll have 0.5745 times 100% times 100%. So we have efficiency of 57.45%. Yan. So next is the mean effective pressure is equal to work total over B1 minus B2. So we already know that the total work is 803.59 over B1 is 0.944 minus 0.0524. So using again the calculator, 803.59 over 0.944 minus 0.0524. So there, we will have answer of 900. Ay, permanent waves 901.29 PPA. So that ends the question 2 in combustion engineering.